Hey everybody, this is Larry. This is day 26. Is it 25? Nope. Well, we'll know when it loads 25 of the date. Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's one. New 21 game. Oh, I haven't done this one before, so I haven't had a video before. So hopefully you're patient and all this stuff. 837. Okay, Alice plays the following game loosely based on the game 21. You start 0 points and draw cards until, like blackjack. While he lets the keep on, during each draw, it gains an integer randomly from one max point, where max point is an integer. Each draw is independent, and outcome has equal probabilities. Alice stops drawing numbers when she gets k or more points. Return the probability that Alice has n or fewer points. Okay, and then some tolerance. So what's n again? N is okay, n is the number. Max points is basically make sure I understand the variable. Okay, so you draw a card from 1 to max points, and then you keep drawing until you have more than k. And this is 10 to the 4th. Okay. N or fewer. What's K? Oh, K is keep drawing. Okay. Okay. All right. The variable names that they use are a little confusing, so I think I just had to get through that in my head. Also, now that look, I'm still in Georgia. I'm still in Batumi. I need to put up more drone videos for you hungry people out there. But yeah, as you can also see, I kind of need a haircut. I've been traveling for a little bit. I need a haircut. Anyway, okay. So now that we understand the problem, let's think about what we should do. Okay. Um, my initial intuition is dynamic programming. But the initial one is going to be max points times n or something like this. The naive one, anyway. So, excuse me. So I have to figure out how to do it. Hmm. Um. Wonder. Hmm. Let's see. What is the probability to enter at 1? What is the probability to enter 2? So it starts at 0, and then binomial the way up, right? Yeah, I guess this is just binomial. I mean, it's not just binomial, but the distribution up until k could be, maybe. I don't even know if that's true. Because basically you only care about from k to n, and everything that's smaller than k is binomial distribution, right? No, that's not true because I'm confusing my combinatorics. I just woke up. That's my excuse. But okay, no, it's not binomial because you can have variable number of dice toss or whatever it is, or cards, I guess in this case, a number to get to a certain number. Hmm. I don't lie. This is stumping me a little bit. Uh, can I use heap? Is this still a heap problem? Sorry, friends. A little bit tired. Um, hmm. Trying to think. I mean, the other way that you can do it is sum up the probability of it happening after one toss, and then two toss, and then three toss, and then so forth. So that would have to end after k tosses, because you always get at least 1 point, right? What would that look like? This is kind of hard for a medium, isn't it? Or maybe I'm just not thinking correctly. Hmm. Sorry, friends. I'm thinking, like I'm basically thinking through whether it's worth doing the naive dynamic programming and then optimize it. That's a trick that I don't use enough. But that's like a really hard. I don't know if it's really hard, but it's a relatively hard thing for a medium. But maybe I'm over guessing it might a little bit. Um, so you want to get under n. We're over k. Okay, or more. Hmm. I do wonder if I'm missing something like really obvious. But uh, yeah, I mean max points. Wait, did I miss? Oh no, max point is 10 to the 4th, right? So that's not really naively DPable. Can we write out the formula? Does the dice count matter? Hmm. Because basically, okay, let me try. Okay. Huh. Because it's a little bit awkward, right? Because one will never be possible, for example. Well, I mean, except for when you stop it the first time. Because after two, you roll the dice twice. I'm also trying to think now whether it is easier to do the math on going over, right? Like what is the math on going over? Um, that part is still kind of hard, right? Hmm. All right, maybe I have to use the sliding window DP. Let me think about it. I just thought that it's too hard to do it, to be honest. Um, but I don't know. Okay, so basically the way that you would write this is, let's just say you have, I mean, I'm running out of ideas, so I'm just going to do the naive thing and then see if that helps us at all. Maybe not. So definitely, in the future maybe skip ahead or something. But okay, so let's just say we have a calc thing. We have the current number of points, and current number of points is all that matters, right? And then is that true? I guess so. So maybe I was wrong about this. Yeah, I guess the current number of points is all that matters. And then the current number of points, if current is, greater than or equal to n, return 1.0. If current is greater than or equal to k, return 0.0, right? Again, and then otherwise, naively you would do something like for I in range of max points, maybe 1 and max point plus 1, I guess. Total is equal to 0.0, and then it's just total 1 over max points times, I guess just calc, right? Calc current plus I, something like this. And for now, I'm going to cheat and just use cache, just because I want to see if this is correct at least, right? It might time out, but okay. Did I misunderstand the things again? N is, less than n. Whoops. Okay, I mean, that's fine. Less than or equal to n, or? Okay, yeah. Oh wait, that's not right. It's k and then otherwise. Otherwise, if it's greater than n. Okay, my base case. Wow, I'm really bad today. Don't even have my base case correctly. Okay, is this right now? Okay, so this is right, but the problem is that it's too slow. It's gonna be like I said. I really thought, I think the reason why I didn't write this out and think, I mean, now I think I know how to do it, but the reason why I didn't do it quickly is because I really thought that the number of count matters, but yeah. Okay, so now the first thing I want to do, and maybe there are multiple things, right? It's okay. It's try to figure out how do I explain this in a good way? But but basically, okay, maybe this is a good idea on the optimization. Sorry, friends, I took really long on this one, but now I know how to do it. It's just that, to be honest, I really thought that this technique is kind of a little bit on the harder side, but to be considered a medium, but maybe not. But okay, maybe this is a easy optimization. I always have to write it out, but okay. But the idea here now then is that, well, two things. One is that you can take this out because that's just how division works, right? And then now that you have this, then you can see that this is almost like a sum, right, of a lot of numbers. And then basically it's just rewriting this in a way such that we get the total. You could kind of do it in a prefix sum kind of way, right? Yeah, you could do it in a prefix sum kind of way if you want to think about it that way, because basically what you want to do is you're just calculating the sum of max points, number of points, and then you move that sum, right? So you could do it in a couple of ways. You could do it with what I call a sliding window DP. I don't know if that's quite the term. I don't I haven't been following up on the literature. But or you could do it with prefix sum or whatever. But that's basically the idea, right? So okay. So the way that we're gonna I mean, I know how to do it already, but I'm trying to figure out what's the best way to explain this, right? So okay, so let's rewrite this as bottoms up real quick, right? So yeah, and just to kind of keep it consistent, I'm gonna do something like, so dp is equal to I don't know what's max points. I don't know, just say like 0.0 times max points times 2 or something like this. Because you can go, well, maybe like n plus max points or something, right? Yeah, because you can only go n plus max points, maybe plus 1, just because I don't know. And then to keep it consistent, k, so for I in range from k to n plus 1, so inclusive, dp of I is equal to 1.0, right? And then everything over n is going to be 0, so we already kind of covered that case, right? And then now we want to do it backwards the way that we do it. So for I in range of k minus 1 all the way to 0, right? dp sub I is equal to sum of dp sub I plus 1 to I plus max points. Yeah, so something like this, right? Over max points, and then we just return dp sub 0, right? So this is just basically me rewriting what I wrote, and this is a little bit awkward because it's wrong. Oh yeah, I forget that. I always forget the bounds for these things, but in any case, yeah, it's a little bit awkward than usual, because usually people do bottoms up going, if you want to say it, from left to right. I'm going from right to left, but it's the same idea. It's really in this particular case, you know, and that's, I mean, not to kind of not to humble brag a little bit, but that is the benefit. Sorry, I'm looking for lighting. That is the benefit of, you know, like actually learning the stuff, is that you're flexible in weird ways, even when it looks really awkward, right? Okay. So now we're trying to sum this, right? And here we can do, as I said, you could do two things. You could do prefix sum, or in this case suffix sum, or you could use like a sliding window thing, right? Because you notice that every time you go from left to right, all you do is just the sum of this, and you know, going from you know, so I is equal to, or dp sub I is equal to this, right? And then dp of I minus 1 is equal to yeah, I mean, I don't, I mean, it's not that bad. I just, to be honest, I just really thought that this would be not be a this isn't a medium technique if you ask me, but I don't know sometimes. But yeah, but if you look at this, right, then the difference is that, you know, this is equal to this thing minus dp of max. Let me put this on another line so it's easy to read. So this is equal to this minus dp sub I plus max points plus 1 plus dp sub I, right? So that's basically it. So if you kind of put this into a variable, then, you know, yeah. So let's do that, right? So current is equal to dp of k to k plus max points plus 1, maybe. Yeah, I think no. Yeah, because we start with k minus 1, so k plus 1. Okay, yeah. So this is the current, right? So then now we can, let's remove that for a second, right? So then now this is current. So then, so this is current for that, right? And then after we processed, so current, we want to subtract, oh, yeah, okay. We want to subtract dp of I plus max points plus 1, and then we want to add back dp sub I, right? And I think that's it. Okay, maybe, oh, whoops, I forgot the sum. Did I have an off by 1? We worked for the other two is kind of actually crappy example, so maybe that's why. It is very possible that I'm just off by 1 somewhere. It's very awkward though. I mean, the way that I wrote it is a little awkward. So we do it for k, right? And then maybe it's off by 1 in that way, but this doesn't make sense. So okay, yeah, I was just off by 1 on the addition. But yeah, you just have to follow the formula. I just didn't. Okay, right, and then now you could test some big numbers if you like. What is it? N is, I don't know. K is, I don't know, 6,000. Max points is, it doesn't matter, right? Yeah, as long as it's fast enough, the answer is going, oh, and it's right. You know, obviously fast enough, but also the right answer. This is a very tricky question, to be honest. I mean, I think maybe in a way that I play myself a little bit, like I said, in that I really thought that, so this technique I didn't expect to see on a medium, so that's probably why. I mean, otherwise this is okay. I really expect this to be this is a hard version of a medium, to be honest. So if you don't get it or if you struggle with it, I mean, you see me struggle with it, so, you know, so don't feel too bad about it. But yeah, that's all I have for this one, though. That's all I have for today. Let me know what you think. Yeah, let me know what you think. Let me know if you got it very quickly and beat me. So yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.